This is a secondary winding here, these two, and 4.7 ohms is primary winding. Nothing. Hello again, everyone. Welcome back to the basement shop. I'm going to be starting on a vintage radio restoration. This is a Philco Model 70 called the Baby Grand. 1931. It is AM only. Uses 7 tubes. Uses the old 4 and 5 pin style tubes. Hopefully they'll all be okay. If not, we have a couple of these that we can replace, but may have to hunt up some others if we find some bad ones. This is a mahogany cabinet. I'm pretty confident in saying that just by being as dark as it is. Let's take a closer look at the cabinet. And we do have some issues. The decorative part of the speaker grill is broke. This one is broken also. It looks like it's been glued back. This one it's loose, so got some delicate repair to try to accomplish on that. The knobs. I've looked online and I've seen all kinds of knobs on these radios, but I think originally it had this type knob, a larger one here and then 3 smaller ones here. Now I also did see one that had knobs that looked like this for all 3 down here, and one like this for the tuning. So I'm going to come up with some knobs. Definitely can use this one because that looks like a Philco knob. Here's a Philco 60 that I restored. And this is a knob off of the 70. Same as the 60. Yeah, the finish is got a lot of crazing. I'm assuming this is lacquer. And you see it's starting to peel and crumble. Got a piece of veneer missing here and here. The rest of this, I think I can refinish it. It does look like it's had some water stains here. It's kind of darker looking. We'll see once we get into that. This other side, braces come unglued, but the veneer is okay. Little piece missing there, and a piece missing, a few pieces down there at the bottom, but nothing major there. The Philco design patent label, and there's the model number, Model 70, with all the patents listed that Philco had. I think that's an original speaker, so hopefully that's good. This bottom, it's got some separation here, but that can easily be glued back. Looks like the wood's dried out, just split. So that's probably what's caused that. We got our metal feet, and we got a chassis screw missing. That's pretty typical. We got 3 of the 4 that are there. So let's pull the chassis out and look it over. Got the 4 knobs pulled off, and this piece in the grill, it fell out when I turned the radio over, so we want to hang on to that. Hopefully we can put all of that back. That piece is loose too, so we'll take it out. Okay, let's pull these screws out. before we set this cabinet aside, I think that says August 1931. Okay, pull this speaker plug off. Well, not having much luck yet. Well, we left a screw in. That's why we're not having much luck. I thought I took that out. I think it's loose. It's just jammed. Oh yeah, that loose. That made a difference. Now I bet it'll come out. Nothing going on in the cabinet. No tags or anything. That's pretty interesting. Look at that label. It shows small knobs for those three lower knobs. And nothing jumps out at me here as being in bad shape. Yeah, we got some rust on the tuning gang, but won't hurt anything. It is a big transformer. Looking at this dial, yeah, it's all there, it's just really faded, as it should be. 90 plus years old, but still intact. It's not broken. And does it tune? Yes, it does. It turns. So we want to be careful with that. Let's look underneath. First thing I notice, we use the Bakelite assemblies like Philco used back in the day. Got 1, 2, 3, 4, 5, 6. Not a lot going on other than that. We do have some electrical tape in places. Cut that wire and then taped it back. And here, we'll have to see what's going on there. The next move is see if I can find a schematic on this. Definitely going to need one to know what I'm doing. I do have some brittle wire. See that red there, how that's breaking? Maybe you flex it. And that black, I think it's the same way. Yep, hard as a rock. This black wire. That looks like that's cloth covered there. And I think the power transformer, maybe they're cloth covered, so that's good. And pretty obvious these aren't original caps here. Notice they had been fastened underneath with studs and nuts. So we'll see what we can come up with for that. Make it look a little more original. And fortunately, have a schematic. This is a Beatman 1926 to 1938 and the model 70. So there's a schematic. Doesn't tell you voltage readings, but it is a schematic. And on the other page, this is a replacement parts list. So that'll be helpful. At least we can see the layout of the parts, what it's supposed to look like. It says knobs. So we did have 3 small knobs that matched and 1 large knob. I would say just like the 60, printed out the schematic. The Beatman's is good, but by the schematic being in a book, it's kind of hard to see all of it, and you have to fold the pages back. So that'll work better. First thing we're going to do, we're going to test the tubes. This is my RCA WT-110 tube tester. Uses the punch cards. I had the punch cards for the 27 tube and the 80, but I don't have a card for the 24 or the 47. So I'll see if I can make one for those if they're listed. Yes, they are both listed on the punch card list. I do need to make a card, so this is how that's done. Use a master punch card and just lay it on top of this card stock. This is about the same thickness as the original cards were. And take a pencil and mark each column that needs to have a hole punched in it and each row. And we have to cut it out where it'll be the same size as this card. Punch a hole in it to store it, and then we got to punch the notch here in the bottom where it goes in the tester. And here we have the holes marked with the pencil. Now we'll punch them out. Okay, this is for a 24 tube. Here's a card I made. The notch does store in the upward position. Now there's a metal rod that holds all of these cards together. I have it removed so I can add more cards. Now this is a 5-pin tube, so we do need an adapter. And here's our 5-pin adapter that I made that allows you to plug the tube into an 8-pin socket. And we have filaments. It does check weak, so we'll calibrate. Yeah, we're in the middle, so that tube is weak, but it does light up, so at least the filaments are good. Next we have a 47. So let me make a punch card and we'll test it. All right, the 47 is good. So good tube. Yeah, these punch cards are a little frustrating whenever you don't have one and you have to make one for a tube you want to test, but good thing about it, you only have to make it one time. And we put our new cards in with the others. Slide the rod back, thread it in the front. Now we've got to test an 80. That's a rectifier, and there it is. There's my 4-pin adapter. Well, unfortunately, 80 tube has an open filament, and I even checked it with the meter. And so we're going to need an 80. And I have a couple of those, I'm pretty sure. This is a Philco 80. Let's see if it tests okay. Yeah, we've got filaments. Well, not testing the best. Now this tube, you're supposed to test P1 and P2. There's P2. A little better than P1, but not much. Here's another 80. Now this is a later version. As you can see, it's a small glass tube. Filaments, and it's really good. Both P1 and P2 checking up into good. So for troubleshooting purposes, we're going to use this first one, this Philco. It probably work well enough to troubleshoot with. think there's 4 more tubes under this shield, so we need to pull that off. And just a couple of flathead screws here, just a clip here in the back. This clips over like that. And just had to loosen these. Slipped right off. Okay, let's check these others. I'm trying to be really careful when I'm pulling these caps off. If you don't watch, you'll pull the cap of the tube loose. And I just wiggle it when I pull it out. So I changed the rectifier, and we still have that weak 24 tube, but we're going to troubleshoot with it in. Put the tube tester up. We're finished with it. Put our adapters back in. There's a bad rectifier tube. Put it over with the cabinet and the tube shield. So, how do we begin? Well, first I want to check the power transformer. Bottom of it right here, all the leads coming out. Power supply is always the first thing we want to get going. Not going to work if you don't have any voltages. So I've removed the number 80 tube, the rectifier. And let's check and see if we have AC coming out of this transformer. First I'm going to check for approximately 5 volts here, filament winding. And we can test that right on the tube socket. Be across these two. Hey, we got 4.88. So that's checking good. Now we should have probably 600 volts on the other two pins of the 80 rectifier tube, here and here. And we do. We have 588, 587. And I'm on 100, a little over 100 volts. So that's a good sign. And another good sign, our dial light. So we know that winding is okay. And it's right here. So we know we got voltage here. So we're going to call that transformer good. This is one of the main filter caps that they've replaced. There's the other one down in there. But you can see how they've got them mounted. They're just nuts on the screws. And if we can get this thing working, we'll change all of that without putting any kind of voltage to the radio. I've done some resistance readings. We should have about 250 volts roughly when this rectifier tube's working DC. And there's the filter cap that I just showed you with the wire that's all disintegrated, the coating. We got a short from here to here. So that's why I have it clipped loose. Let me show you. This is a ground, a common ground that they've tied both them caps to. Kind of a mess, but that's what it is. I'm going to clip onto this red wire going to the replacement cap. Shorted. And that was connected directly to the rectifier tube. So that's why I clipped it loose. Now this other one, here's a red wire going to it. The ground is common to both. And on it, we seem to be no shorts. We got 11 megs there, so possibly the bottom one, this one, possibly it's okay. But this one we definitely need to put a cap in. Leave this one unhooked. And it goes to right there is the connection on the tube. Was this the reason that the filaments were open on that 80 rectifier tube? Maybe. Just clip a cap in here temporarily. Should be 6 mic, I think. Yeah. We'll clip a 6 mic cap in to ground. And let's see if we get anything. One more thing on these 4-pin tubes. How do you know which pins are the filaments? Well, if you look, 2 of them are larger than the other 2. So these 2 pins here, those are the filament pins. Cap temporarily bridged in. And we are producing some DC voltage. We're up to 200. On about 100 volts. There's 100. Drawing about 0.6 of an amp. So, do we have anything going on? Now we're up to 237, 238, so that's about normal. So bridging in this one filter cap has the B plus up to where it needs to be. We got 270, that's plenty, coming right off the rectifier tube. And the other side of the filter choke, we have 260. But if we check our voltages on this first number 24 tube, that's this one, back in the, I call it the antenna input stage there. Pins 1 and 5 are here, that's the filaments. Pin 2, we should have about 200 volts. And we have 2 volts. Now, pin 3, we got 180. Pin 4, we got 20 volts. Goes directly to this transformer. And here it is on the schematic. This winding here goes to pin 2, number 24 tube. And then we have our 250 volts approximately down here coming in. This secondary winding's okay, but this one is open. I'm going to pull that out, see if we can repair that. So that'll do it for part 1 of the restore. We'll see you in part 2. Thanks for watching. We hope you've enjoyed the video. And if you did, how about giving us a like and subscribe to our channel? Thanks.